So now after having had a look here in the hangar, we are now here doing a little bit an interview. I have a lot of questions, so I'm prepared. So now basically we have seen the workspaces, we have seen what you have for equipment here. So what do I have to do to become a member of the ARIS team? Are there some prerequisites that I have to meet, or
Yes.
what do I need to become a member?
Yeah, so for ARIS team, we are a student-based organization. So this is our main point. Like if we're hiring, we're always hiring for students, of course. But now we have the limit that we only hire second year and onwards, just because it's the workload in the first year is very high and you're not used to it yet. But this is from like an organizational point of view. But else than that, we look for qualities like wanting to go in a team, being motivated. That's probably the main part. That you show us how motivated you are. It doesn't have to be by any sort of like you wrote a paper, you had this and this. It's mainly like for us, we always do interviews with the people and we want to know what they are, if they want to work in a team, what they can contribute, if they know what they're doing as well, because it is time costly. But on a grade level or something, there's no requirement. I think ARIS has shown that like a lot of quality can come from many different people, and we don't need like a 6.0 average or something like this. We just want to see the people, what they want to do, their passion, their motivation, the team, the ability to work in a team. And if that's given, then we're more than happy to make you improve. And it doesn't even have to be exactly in the area. So just because you do mechanical engineering, you don't have to do mechanical engineering. Or if you study medicine, you don't have to do anything here because we don't offer that. But you can always go cross. You can always try to do something new. So if you're a mechanical engineer and you're like, oh, I want to learn something about computer science and how to program it, how to look at my algorithm, how to do connections to the real world application as well, that's of course possible. We can teach. We have that in the past with coaches who support you, who bring you to that topic. And if you're willing to commit and learn something new, you're always happy here.
Good, fantastic. So thank you for the overview. So now let's come back a bit to you. So you're the team leader of the Project Nicollier. Can you tell us about your main responsibilities in the team? What are you doing? Like, what is your daily approach to, or what is, or did you have a mentor who taught you about rocketry, or was it autodidactic? How did you find your way to become a team leader in this team? Yeah.
Yeah, so I lead the team. That's what my main responsibility is. So what we do is we have the overview, or what I do is I have the overview about the whole topic, what is going on, the timelines, how we connect, and the budget to make all of this happen. And you basically come all of this together. And the main point is coordination. So you have the inputs from TTLs, and TTLs are definitely the most skilled of what they're doing, so they are the team leads of the teams. Then we have the SEs, the system engineers, which have an overview from a technical point of view above the whole rocket, and so they should be able to tell me about every subsystem in some advance. And then we have myself as the project manager, who just focus all of this. I have the last call at the end. So far, it has never happened that was necessary, but we come together, we sit together, we coordinate timelines, what would we want to achieve, how are we in that regard. And of course I'm also the bridge to the board, where we look for our point of view, like what are our goals, how is our team standing in this organization. And for like mentor, for me it was a huge thing with my previous PM. So I was part of Project Nicollier as well, and there the PM there is Yannick Vogava. I had a lot of contact with him, and although I would say that we have very, very different types of leading, or like the approaches we try to do behind this. I think the things he told me in the long meetings we had together, where we discussed things, where I searched for advice, were always very applicable, because it's more about like finding yourself, finding your own way of leading the team than just saying like this is the straight answer. So he was a huge help for me, and he really helped me, especially with the leading of this project here.
So you told me you're studying physics. So do you have already any concrete ideas or plans about your future or your career? So after maybe you will leave ARIS, what's next? Or
not concrete, I have to say, not in any way. But for me, it's I want to stay in the sector if possible. So for me, just space flight in general is super interesting, and I really like the technical perspective as well. That's where I came from in ARIS as well, having those technical aspects. So I would say I'm somewhere on the bridge between physics, what I study, and mechanical engineering, what like my interest also is. So I would like to stay in that area, also in the project management area, of course, because that's something I really enjoy. But I could see myself going all the way into like a more physics-related topic as well, doing data analysis there, looking into astronomy, stuff like this. So that would be my ideal goal. I couldn't name a company or something like this. Just see where it develops. But I'm confident that something will come up. We, ours in general, have a quite good structure of going to places like this. So I hope it will come from me as well.
Sounds exciting. Then let's now talk about your project or your project name. The team was named after, apparently after Claude Nicollier. So the first and only Swiss in space. Until now, I mean, soon it will also be a second, probably, but until now he was the only Swiss in space. So please correct me if I'm wrong.
No, that's correct.
Yeah. So, do you have any personal connection to Claude, or why did you name it, or why the name Nicollier? Yeah.
I mean, previously to the project, we didn't have that big of a connection to him. I think he's just a very inspiring person, being really on the forefront of, or like a pioneer in the area of spaceflight here, especially for Switzerland. And I mean, he's done great input. He flew on missions to the Hubble Space Telescope. I've visited some of his lectures. They were extremely inspiring. What he has to say, and from now on, I can also say he's a super nice person. So I think in many regards, he just embodies what we would want to go for, with innovation, pioneering from Switzerland on into the world. So that's why we chose to do his name. And yeah, now that we have the project and his name, very lucky to have his support. He's really active with us, with what he does. So he's visited like one of our reviews, for example, where he gave some input, some really good input as well. Okay. And yeah, he's visited some of our or listened to some of the launches, reacted to what we do, got in contact there. And so every now and then you get contact, you talk to him. It's really amazing.
Yeah, by now he must be 80 years old.
Something in that area. Yeah. I couldn't exactly tell you, but it sounds about right.
So can you give us a brief overview about the project again? What are the main goals? So next week we are hopefully seeing a launch. So can you just give a wrap up about the main goals, and what is the impact of the project for future teams at ARIS, and has it even an impact on private or governmental space programs, what you're doing here?
Yeah, so our main focus of the project is the guided recovery system. It is really like a rocket, and in the area of space flight that we're in right now, we just see that rockets have to be reusable. This is just one part which grows more and more important, both on an ecological and economical point of view. It's just super important, and that's what we go for. And we take a little bit different approach, so we use the guided recovery system on a parachute basis. So this is different to what you commonly see SpaceX or other thrust vectoring. So thrust vectoring is like moving the engine around. We don't do that. We use a parachute, which is steerable using those electric motors. And that's what we try to see in the launch, is that we ascend, that we come to altitude using the COTS motor, and then come down safely, fully recover the rocket. That's our main purpose. So that's what we want to achieve, and we want to aim for a point and try to achieve to reach that, and just test our system and show that our system works. And for us, the impact is big, because if we want to go bigger and bigger, and that will be the term long time. So we do a lot of engine development in ARIS, although we don't do that ourselves. Not Project Nicollier, that's what I mean with that. But we want to go higher. We want to increase the size of our engines, and thus go higher in apogee. And all of this is very expensive, and the parts themselves are just a big deal, and also just the manufacturing of this takes so long, or in-house parts, combining it, testing it, and if we have the capability of recovering them in a safe manner, then we can reuse them and reiterate on our concepts faster, and so we can make changes so much faster, not just in a year, but like every month, every 2 months, something like this. So for us, this guided recovery system is really what we want to achieve there.
Yeah. You mentioned the cost. How much is or how much did you invest, or how much is the cost of this rocket next week that we will launch?
Yeah, the rocket itself is hard to measure actually, but the whole budget of our project is around $250,000.
Okay.
This is mainly value in kind, so something we got for free from our very valued sponsors, and yeah, so we take that in and build a rocket. I think one rocket itself would be somewhere 20 to 50,000. It's hard to measure that.
So your sponsors, do they also profit from the results of your research, or
to some extent? We try our best to do to give them back and to show them our valuation first of all, but also to give them some something back for their efforts. They don't get our research, they don't get our results, they can't use the technology afterwards. It's important to us that our technology stays what we develop and that we can develop as an organization, keep on growing. So it's not, they don't have access to our technology in that sense. What we try to do is to give them exposure from our points of view, show enthusiasts like companies which are related to that field or which of course support us. And also like the students which are in our project, coming from various universities, high-ranking universities, which obviously are highly motivated to do a project like this. It is a nice contact for the sponsors to have to have access to students like this, where you know they put in extra work. They don't just do the limit; they try to go above and beyond that. So that's the main part where sponsors like get in contact with us, get their name out to students like this. And some do internships or jobs at those companies later on.
So we talked about investment, so it's not only the money side, it's also time.
Yeah.
How much time did you invest for this whole project now that you worked towards this, it's culminating in next week in this launch. How much time did you invest? Personally and also the team, yeah.
I think the workload can't be underestimated. It's immense. For myself, like throughout the year, somewhere between 20 and 40 hours a week. It really depends on the week. Sometimes there's now in the launch preparations, we spend so much time doing calls, the preparation, setting it all up. That is for myself. The team in general, that still depends on the position, but we always estimate around like 15. For the TL, it's probably 20 to 30 hours a week, which they invest in making all of this work. And I mean, we're like 43 members, so you can accumulate this, and then over the span of now 40 months, that is a lot of work that went into the project in total hours. So yeah.
Nice, yeah. So this is often because the people don't see behind, they just see the rocket launch and then, oh yeah, okay, that probably took 1 week to assemble it. No, it's not. So now a question concerning the administrative part. Do you carry out these launches on a regular basis? And what kind of permits are required to carry out these launches in Switzerland?
Yeah. We don't do it yet to the extent we would like. We would like to carry out more launches more frequently. That is always what we're aiming for, because the best way to test the rocket's capabilities is to fly the rocket. We do a lot of tests before to ensure that we don't just like try something and then see it fails. Like if we could have avoided it with the test before, then we do the tests, of course. But seeing the full system is always the best proof of your rocket working as intended. In Switzerland, of course, the area is quite populated, so it's hard to find a spot, and safety is always a big concern. To mitigate risks there, we go into mountain ranges. So if we, either during the rocket start itself or during the landing, we would lose control at any time, or the rocket would be non-nominal, the rocket would always fly into a mountain, worst case scenario. So we would always lose the rocket.
Which you had already, you told me.
Yeah, we had that in previous years where we lost the rocket.
Yeah.
But from a safety point of view, it's very good. And the permit's actually quite easy, or we put a lot of work into making it easy or understanding. But in the category that we fly in now, we have a model rocket, and for this, no special license needed. We buy the rockets, and we have people who are licensed to buy rocket motors. But the airspace itself, we block it. We are in contact with air traffic control and the BATSL, which is like civil.
BATSL, you have to explain.
Yeah. That's
you can say it in German.
Yeah, it's a Bundesamt für zivile Luftfahrt, so it's the responsible for the airspace, for the civil airspace. So we had a lot of contact with them, a lot of work, but and we declare what we do. We reserve the airspace for us, and then we also, of course, observe the airspace during the launch itself. But else than that, there's no permit needed. You have to find the area, and for this we work with military, which provide us the area. There we have to get their writing to the approval that we are allowed to launch there. But it's also all sorts of like you put it together multiple pieces, and then it works. There's no like one license that is hard to obtain. It's all just making it work together.
So let's now come a bit to the comparison of your rocket to really the state-of-the-art rockets like the Falcon 9 or Starship. So what are similarities and what are actually the main differences? So, or maybe it's a stupid question, it's already the dimensions are so huge, the difference, but
it starts even before that. Like the scope is just so much different. That's where it actually started. Like rockets like Falcon or the Starship, they intend to go into space and beyond that, and just travel a lot and carry out like lift as much as possible up into space. And long term, we might want to go there. This can be discussed with like carbon rockets and stuff like this. But our intention is more to be on a small scale. So what we are is a sounding rocket. The definition behind this is a rocket used for scientific purposes, which carries out experiments in lower Earth, like inside the atmosphere, and in non-orbital flights. This is the vast, like the difference is huge to what SpaceX or other companies like that do. On a technical level, we are much smaller. For us right now, we use a different propellant. We use solid. All newer rockets use bi-liquid engines. We are currently developing that as well, but it's not implemented in our rocket yet. And on this level, and then the sizes are just different, and this makes the parachute system quite applicable, because on very, very large scale rockets, the weight of the parachute doesn't outweigh the benefits it has compared to something like thrust vectoring, like SpaceX uses it. But on the scale we are, and a little bit beyond that, or actually a lot beyond that, but the parachute system really has its benefits. And so all the rockets which go into like the sounding rocket category, which are non-orbital yet, they will really benefit from what we do.
Okay, thank you for the information. So you mentioned the motor. It's a so-called COTS motor, commercial off-the-shelf motor. So that means you can buy them. And where do they buy them? I mean, I didn't see a COTS motor in the grocery store or pharmacy. It's like, a rocket a day keeps the doctor away. So now, do you need a special certificate or a special training to get access to these commercial parts of your rocket?
Yeah, as you say, it's not easy in that sense to get it. It is easy, but you don't get it everywhere. So you start and you do licenses. This is like Tripoli is the main player in the US mainly, but also here in Switzerland. And you go to those launches and you get your certificate. So you start with very small rockets, which go to like 300 meters. And then you have your Tripoli 1, and then you do 1 to 900, then you have your Tripoli 2. And with this, you get the licenses. And then you are allowed to buy those commercial off-the-shelf motors. They vary in size, and depending on your license, you are allowed to buy different sizes and different power. They're like different classes of them. And we as a student team, there are some limitations or like some improvements for us. It's a little bit easier to get those motors because they expect, okay, yeah, you don't have the time to get all the way through the licensing. So we have a little bit of benefit there. But yeah, we buy them from the main supplier here in Switzerland, and who provides us with a lot of help there. And that's what you get them from. But yeah, you have to have some sort of license of those Tripoli licenses to obtain a rocket motor like this.
Okay, so
at least of this size that we have. That's one.
Yeah, so I cannot. It will not be under my Christmas tree. So how many team members do you need to finally assemble the rocket like next week? So, and are they highly specialized or in what they do? So, I mean, someone who is responsible for the propellant, for example, can he handle also the engine or the recovery system?
I mean, in theory, yes, but actually no. Like we see that, or during our tests or dry runs, we have seen that it is. Like in theory, you only need 2 people to assemble the rocket. Like it's, if everyone would know everything, or if you have 2 people which knew everything, you could assemble the rocket. Lifting up the launcher is a different story. For this, you really need like 16 people. But it just makes much more sense to have the people who are specialized on that, and all the people who will participate in the launch in a week will also, just have done 2 dry runs minimum in their field, gone through the procedures, know what they're doing in their time, and are part of the sub team that did all of this. So the people itself in the teams, so the team members and the TLs are highly specialized. They sometimes know they do know the intersections, so they are the interfaces between like recovery and avionics, or avionics and structures. Like they know what the interfaces are, and then they both know it. But they are limited to what they know about the system. Of course, because of interest days, they heard left and right what other teams do, but the people having the overview are really the SEs. That's the main purpose there.
Yeah, we're talking about the launch already now a few times next week. So can you give us just a quick overview about the day's program? So what will it be like? What can we expect there?
So we will get up quite early. We get up at around 4 and then try to be in Wichlen around 6:30. That's when we're going to start. We're going to do the assembly, first of all, of the infrastructure. So we're going to set up power cables, tables, tents. We don't know. We hope it won't rain, but we don't know that yet. And then we're going to start the assembly at around 8 or 9. And then we're going to go through all the steps. So as soon as fully assembled, around 10, 11. That's when the rocket will be fully assembled. And then we bring it to the launch area, which will be assembled in the meantime. We have 2 people doing that while the other do the other stuff. And we're going to lift it up. Then we're going to do the pre-flight checks. So see if all systems are ready, if the range is clear, all of this. And then we're going to lift off around 1 p.m. Hopefully, and recover the rockets, disassemble everything, and bring it back to the hangar.
Cool. Yeah, then let's look forward for next week. Thanks a lot for the interview and many information that you gave us. So
thank you very much.
Then let's hope everything goes right and we will see a fantastic launch next week.
I hope so, yes.
Thanks a lot.
Thank you.